Good afternoon, students. We'll start with the today's lecture. In the previous lecture, we have seen the magnetic flux and magnetic flux density, right? The concept of this and how to find out the magnetic flux we have seen, and what is the relationship between magnetic flux and magnetic flux density, phi and b. Then we have listed out the Maxwell's equations for the static electromagnetic fields, right? So in both integral form as well as differential form, also called as point form, right? Then we have seen the application of the flux density and flux to the coaxial cable, that is derivation. We have derived what is the flux that exists between the uh, inner conductor and outer conductor of the coaxial cable, and we have solved the numerical based on that. The next today in today's topic we'll start with the next chapter, that is chapter 8 in unit 4, that is another chapter, right? Already we have completed the study magnetic field. The next chapter 8, that is magnetic forces and boundary conditions. But here just I have intentionally made it very light because we are not going to cover this boundary condition, so we are skipping this. So we'll study only the magnetic forces, just like the electric forces what we have seen. Okay, these are the topics that we are going to cover in this chapter. Force on a moving charge and force on a differential current element, the force between differential current elements. One by one we will see. Yes, I have a charge here. First, force on a moving charge. I have a charge q, positive charge, right? Okay, I will place it in the electric field. Whether the charge is stationary or moving, it doesn't matter, but it will experience force in the electric field. But whereas if I place the same amount of charge plus q in the magnetic field alone, right? Let us assume that there is only magnetic field alone, then the stationary charge will not experience any amount of any kind of force on it. But the charge in motion in the magnetic field will experience some sort of force onto it. So we should take care that we should have a moving charge, right? So what is the force experienced by a moving charge? Only in the electric field, that we will have a formula for that. And what is the force experienced by the moving charge in the magnetic field? Then what is the force experienced by the charge overall, total force experienced by the charge due to both magnetic field as well as electric field, the combined effect that we will be studying, right? Force on a moving charge. Then next, second topic is force on a differential current element. Yes, the differential current element means the filament length of the conductor I will be taking. It may be a straight conductor. The current I is flowing in this direction. Then I will place this differential length of the conductor, differential current element, in the magnetic field. Then I want to find out what is the force experienced by this current element or differential current element. Then it is a straight conductor. It can take any shape. It may be in the square shape, right? The current I may be flowing in this direction, right? It may be rectangle, it may be any path, closed path, the current I. Then what is the force experienced by this conductor loop when it is placed in the magnetic field? So second we are going to study that, right? For the closed the conductor loop as well as the straight conductor, we'll see both the formulas. Then force between differential current elements, this we will be seeing in the next class. Right now I will not discuss anything about this, right? Okay, we'll start with the first topic, force on a moving charge. Yes, I have charge plus q, right? And it is moving with certain velocity in the electric field. Then what is the force experienced by the moving charge due to only electric field, right? So we know by the definition of electric field intensity, force acting on unit positive test charge F by Q. So the total force experienced by the moving charge in the electric field is given by F is equal to Q into E. This we know it, right? Similarly, the force experienced by the moving charge in the magnetic field alone, then it is given by F is equal to QV V vector cross B vector. What is this QV? Means charge moving with certain velocity V in particular direction, right? The charge moving with certain velocity V in particular direction under the influence of the magnetic field. So QV cross B. So there is no derivation, just directly we'll take the formula, right? So V is the velocity vector and B is the magnetic flux density, right? Q is the charge that we are taking into account, right? Then whenever there are both electric field as well as magnetic field, what is the force experienced by the moving charge, right? Whenever there are both, right? I have to add this. If it is, let me call this as force due to electric field as Fe and force due to magnetic field Fm. Then the total force experienced by the charge Q due to both electric and magnetic fields, I can write it as Fe plus Fm. Force due to electric field, force due to magnetic field, right? So QE plus QV cross B. Q is common, you can take it E plus V cross B. So this equation we call it as Lorentz force equation, another name for this, right? So Lorentz force equation. So using these formulas, we will try to find out the force experienced by the charge due to electric field, magnetic field, and due to both electric and magnetic fields. We'll solve few numericals based on that. Okay, we'll take up this numerical. The point charge Q is equal to 18 nanocoulomb, has a velocity of 5 into 10 power 6 meters per second. Right, magnitude is given. In the direction of, in which direction, that is AV vector is given. In this direction it is moving. Calculate the magnitude of the force. They are asking magnitude, right, not the vector. First we'll find out the vector, then we will take the magnitude. Calculate the magnitude of the force exerted on the charge by the field. Part A, magnetic flux density is given, right? So whenever there is only magnetic field, find the force that is experienced by the moving charge. Then part B, electric field is given. Whenever there is only electric field, find the force experienced by the moving charge. Then part C, both B and E, both magnetic flux density as well as magnetic field and electric field, both are present acting together. So we know these three formulas, so we'll make use and we'll solve it. So I'll take up part A first. So vector B is given, right? So the force F due to the magnetic field M, it is optional, it is not mandatory to write M here, right? So we know the formula. I'll just alter QV vector cross B vector. This is due to the force experienced by the moving charge due to the magnetic field, due to magnetic field alone, right? Because B is given, right? So this is the formula. Q we know it is 18 nanocoulombs. What is V vector? V vector is this one, right? They have given this millitesla. But what about V vector? Let me first write on V vector. So magnitude is 5 into 10 power 6. This is the magnitude, 5 into 10 power 6 meters per second. But direction is important. In which direction? So it is AV vector. So this 5 into 10 power 6 into AV vector. So let me write it here. 0.60 AX plus 0.75 AY plus 0.30 AZ. Is it fine? So this is V vector. We have V vector, we have B vector. Then first we'll take the cross product of V vector cross B vector, right? So V vector cross B vector. So V vector is in Cartesian system, B vector is also in Cartesian system. We know how to take the cross product in Cartesian system. So right, so AX, AY, AZ. So write up the unit vectors in Cartesian system, rectangular coordinate system. Then write down the components of V vector, right? The X component, Y component, Z component of V vector. X component, so 5 into 10 power 6, I will take it outside. Anyway, it is common. So just I will take only 0.6 X component. Then Y component is 0.75. Then Z component is 0.30, right? So 5 into 10 power 6, I'll take it outside. Then next, B vector, the components of B vector. X component is -3, Y component is +4, then Z component is 6. But they have given millitesla, means milli means 10 power -3. I'll take it outside, right? 3 into 10 power -3, so I'll take it outside. So we'll solve this. What we are going to get? So plus minus plus, right? So plus AX into, so leave this column, leave this row. First I will calculate 6 into 0.75 minus 6 into 0.75 minus 4 into 0.3 minus 4 into 0.3. So I am getting 3.3. Next, minus AY. So leave this column, leave this row. 6 into 0.6, 6 into 0.6 minus, so 6 into point minus, minus 3 into 0.3, open bracket, minus 3 into 0.3. So I got it as 4.5 AZ into, so leave this column, leave this rows. 0.6 into 4, open bracket, 0.6 into 4, close bracket, minus, the next minus 3 into 0.75, minus 3 into 0.75. So I am getting it as 4.65 AZ. But this common thing is there, right? So let me write it into 5 into 10 power, so 6 minus 3, 3. 5 into 10 power minus 3. So this is V cross B. But I want total F. So I have to multiply Q for this. So F is equal to Q into V cross B. So already what is Q? 18 nanocoulombs. 18 into 10 power minus 9. So we'll multiply with V cross B. We have V cross B here. 5 into 10 power 3 I will write first. This one. Then I will write 3.3 AX minus 4.5 AY plus 4.65 AZ. Okay, just will multiply and write down the force vector. So first I will multiply all these things. Then I will multiply with 3.3, 4.5, right? So 18 exponential minus 9 into 5 exponential 3. So I am multiplying this into first term is 3.3. So multiply 3.3 for it. So I am getting it. So let me express in terms of 10 power minus 6. So I am getting 297 AX. Into 10 power minus 6 I will write it outside later on. Then next I will multiply with minus 4.5. Next, instead of 3.3 is over, next I have this here. Next 4.5. So I am getting it as minus sign as it is. 405 AY. 405 into 10 power minus 6 I will write it later. AY. Next into instead of 4.5, next is 4.65. 4.65. So 418 plus 418.5 AZ into 10 power minus 6 newtons. But they are asking the magnitude. So ask find out the under root of 297 square plus 405 square plus 418. But 10 power minus 6 is there. So you take into account of that. Under root of open bracket, once again open bracket, 297 exponential minus 6 whole square plus open bracket 405 exponential minus 6 whole square plus 418.5 exponential minus 6 whole square. Close the bracket. So I am getting it as 653 point, the magnitude of force. Don't write it as a vector, it's a magnitude. So 653.74 into 10 power minus 6 newtons. But 660 they have given, it is wrong. This is correct. 653.74 micronewtons. They are given micro means 10 power minus 6, right? So we will go with part B. I hope if any doubts are there, please unmute yourself and talk to me so that I can clarify. B. Electric field is given. So the force experienced by the charge due to electric field alone, it is nothing but Q. Simple, right? So Q, what is Q? It is 18 nanocoulomb. 18 into 10 power minus 9 into, right? So let me open bracket. So what is E vector? Minus 3AX plus 4AY plus 6AZ. Observe here, kilo is there, kilovolt per meter. Kilo means 10 power 3. Don't leave this, right? Take into account. So then write down the force vector. So let me multiply once again. 18 10 power minus 9 plus 3. So it is 10 power minus 9 plus 3 means 10 power minus 6, right? 9 minus 3, 6 minus sign. So 10 power minus 18 exponential minus 6 I will take. 18 exponential minus 6. Let me take a 10 power minus 6 later. So 18 into 3 just I will multiply. 18 into 3. So I am getting 54AX. Minus sign is there. Minus 54AX. Then 18 into 4. 18 into 4. I am getting 72 plus 72 AY. Then 18 into 6. So I am getting it as 108 AZ into 10 power minus 6. 10 power minus 9 plus 3. 10 power minus 6 newtons. But it is asked to calculate the magnitude. So under root of this square plus this square plus this square. 10 power minus 6 you have to take into account. under root of open bracket 54 exponential minus 6 whole square plus 72 exponential minus 6 whole square plus 108 exponential minus 6 whole square, close bracket. So I'm getting this as 140.58 into 10 power minus 6 newtons. So part B is over. They have given 140 micronewtons. 140 into 10 power minus 6, right? 140.58. Then part C, both B and E acting together, part C, right? So we know the total force, right? It is due to both magnetic field. It is nothing but QE plus QV cross B vector, right? So this is due to both B and E acting together, right? This is due to electric field plus this entire quantity is due to magnetic field. So already we have found out electric field and magnetic field. Just add the vectors whatever we got, or else you can take the resultant of the forces, or else you can add both the vectors. So I have the vector here, I will add it. So 297ax, this is FE vector QV, right? 297ax, then minus 405ay plus 418.5 az into 10 power minus 6. Next, add this vector, FM vector. Here I have this. So this is QE, right? Due to magnetic field I have written first. This one we have written, this one. Next, F equal to QE we have here. So this is the vector. Let me write it here. Plus minus 54ax plus 72ay plus 108 az into 10 power minus 6. So the total force due to both B and D, just add these vectors, 297 minus 54. So I am getting 243ax, then minus 405 plus 72 minus 333 ay, then 418 plus 108, 418 plus 108, so 526 az. So after adding these two vectors I will get this, but we want the magnitude. So find out the magnitude under root of this square plus this square plus this square, right? 10 power minus 6 will take care later. So under root of open bracket 243 square plus 333 square plus 526 square, so close bracket. So I am getting 668. 10 power minus 6 will take it, 668.29 into 10 power minus 6 newtons. This is the magnitude. Don't put vector here, right? This is newtons. Don't just go on adding 140 micronewton plus 650. You can take the resultant, under root of 653.74 whole square plus 140.58 whole square. You will get this 668. That is one way of doing it. Another way is just add the two vectors and take the magnitude of it. This is another way of doing it, right? So 668.29 is roughly 670, right? So this is correct what we have done. Next, this similar to the previous problem. I am leaving this problem to you people. Please take it as a homework. You solve it. Answers are given here. Due to electric field, this is the vector and this is the magnitude. Due to magnetic field, this is the vector you are going to get and this is the magnitude. And due to both B and D acting together, right? So this is the vector you are going to get and this is the magnitude, right? So to do it, I am leaving this to you people. The next, force on a moving charge is over. Next we'll see the second topic, force on a differential current element. I told you that differential current element, it may be a piece of straight conductor carrying current I. It may be in the upward direction or downward direction. If this current carrying conductor, if it is placed in magnetic field, in the magnetic field, then what is the force experienced by this straight conductor? It is given by this formula. The conductor is straight and field B is uniform along it, right? Whenever this current carrying conductor is placed in the magnetic field, the force experienced by this differential current element in the magnetic field is given by IL cross B. We don't have any derivation for this. Directly we'll take the formulas. IL cross B, L vector cross B vector. L is total length of the conductor, right? And B vector is the magnetic flux density, and current I that is flowing through the conductor, right? This is the formula. Then next, instead of which, if I have the closed conductor, let me take square, for example, right? Let me assume that current I is flowing in this direction, right? Then if this current carrying conductor or loop, if it is placed in the magnetic field, what is the force experience? It is given by this formula. It is not only square, it may be this shape also, right? This closed current carrying conductor loop, right? The force that is experienced by this current carrying conductor loops, right, or closed loops or conductor loops, is given by closed line integral of the current element IDL, right? If I take the small piece of the length, I will call this as IDL, right? IDL, differential current. Similarly, if I take the small piece here, so IDL, differential IDL cross the magnetic flux density B vector. We have to integrate along this entire closed path, right? So closed line integral of IDL cross B, but we know A cross B is equal to minus of B cross A, the vector identity. So B is written first DL. So minus sign will come, take it outside. Minus I closed line integral of B cross DL. We will make use of this formula, right? For closed loop conductor, either this is the closed loop conductor or this is the closed loop conductor, right? It may be in any shape, but it should have the closed loop or closed path, right? So minus I closed line integral of B cross DL for the closed loop conductor. For straight conductor, it is F is equal to IL cross B, right? So just further proceeding with this, we can expand the cross product. We know the definition of a cross product. I is written as it is magnitude of B, magnitude of L, magnitude of L, magnitude of B, and sine of the angle between these two vectors, L vector and B vector, that is sine theta. Or else we can rearrange and write it as Bill sine theta to remember Bill sine theta. So we'll be using these two equations, right? These two equations, whenever if it is feasible, based on that we use it in the numerical, right? So we'll continue the numerical. So try to understand this numerical very clearly, right? So by reading this, we have to draw the diagram first. The square loop of wire, yes, it is not a straight conductor, it is a square loop, right? The conductor, the square loop of wire lies in z equal to 0 plane. Z equal to 0 plane means xy plane, right? Carrying 2 milliamps of current in anti-clockwise direction. The direction of the current is also given. Lies in the field of an infinite filament on the y-axis carrying 15 amps of current in minus AY direction. We'll see, we'll draw the diagram so that this entire picture will come to us. The coordinates of the square loop are given, 4 coordinates are given. Find the total force on the square loop or simply loop, right? So first I will draw the diagram. Please try to understand this. So x-axis, y-axis, z-axis. So square loop, the coordinates are given 1, 0, 0. So 1 will come here, right? 1, 0, 0. So let me write it 1, 0, 0. Next 3, 0, 0 along x, right? 3, 0, 0. Next 3, 2, 0. 3 is here. Next I have to move 2 units in y direction, right? So 3, 2, 0. Next 1, 2, 0. X is 1. Next I have to move 2 units. 1, 2, right? It will come somewhere here, right? One, 2, 0. Right? X is 1, y is 2. Is it fine? So this is a square loop. And current of 2 milliamps is flowing here in anti-clockwise direction. Anti-clockwise means in this direction, anti-clockwise. So what is the current that is flowing? 2 milliamps of current is flowing in anti-clockwise direction. Is it fine? Then next, we have another filament, infinite filament on y-axis carrying 15 amps of current in minus AY direction. Means on the entire y-axis we have infinite current carrying conductor on the entire y-axis. This is the infinite conductor carrying current in which direction? Minus AY means in this direction. Current I is flowing in this direction. So what is that current? I is equal to 15 amps. So this is the source of magnetic field. The current carrying conductor has a magnetic field surrounding it, right? So just use the right hand thumb rule, right? So we hold it, the thumb should indicate the direction of current flow, right? Then the folded fingers, right? You just, I will draw the smaller, right? It will be coming in this direction, right? In this direction, right? Similarly, a number of lines I can draw, right? So it will be in this direction. So if I take this current loop which is placed in xy plane or z equal to 0 plane, observe that the direction of magnetic flux lines are going in the z direction plus az, right? They are going in this direction. Magnetic flux lines, you can observe here, they are coming and going in this direction, right? Here also, right? So az direction that we have identified. So this current filament which is lying on y-axis is the source of magnetic field. So under the influence of this magnetic field, what is the force experienced by this square loop? We have to find out. Square loop, which is the conductor carrying current of 2 milliamps. So what is the force experienced by this? We have to find out, right? Okay. Yes, we means this is the closed loop or closed conductor. If it is square or whatever it is, so we will be using this formula, right? F is equal to minus I closed line integral of B cross dl. F is equal to minus I closed line integral of B cross dl. You have to take the cross product, right? So we don't know what is B vector, but we can calculate what is the magnetic field first. We can calculate H vector magnetic field, then we know the relationship between B and H. B is equal to mu naught H, so that we can find out B, right? So since this is the magnetic current carrying conductor, so infinite, so we know the magnetic field intensity due to the infinite length current carrying conductor is given by I by 2 pi rho into A phi. This formula we are familiar, right? So what is I, what is rho, what is A phi? We have to find. I is given, I is 15 amps, right? Then next, what is rho? We'll find out. Observe here. So the perpendicular distance from this conductor to this loop, so it is in the x direction. So this distance, the loop, right? If I consider the point here, it is 1. If I consider here, it is 3. So let me, it is along x axis, let me take it as x generally. So rho is equal to x here. If I consider point here, x is 1. If I consider point here, x is 3 here. I hope you are getting. So rho equal to x. Generally, we will substitute this value of x later, right? Then we came to know rho. What is A phi? Already I told the direction of the magnetic field lines will be going towards z direction. Already I told here, I have drawn here, right? And I have indicated here. So A phi is nothing but plus Az. I hope any doubts you can ask. So H vector is equal to I. Will substitute 15 by 2 into pi into rho is nothing but x here. A phi is nothing but Az. So we'll find out 15 by, okay, let me keep it in this way only, later on we'll see, right? Next we want B, right? So let me assume that this is placed, they are not given, it is in free space. Let me assume that this entire arrangement is placed in free space. So we can find out B. B is equal to mu naught H. What is mu naught? 4 pi into 10 power minus 7, and H is here. So 15 divided by 2 into pi, 2 pi into x, right? 2 pi x into Az. So pi will get cancelled. 2 1 ja, 2 2 ja 4, right? So B is equal to how much? So 2 1 2, right? 2, 15 2 ja 30. 30 into 10 to the power of minus 7 Az. So we can write it as 3 into 10 power minus 6, right? So 10 power minus 1, I will take it here. 3 into 10 power minus 6 I can write, right? Can I write? I can use this also, or else I can make use of this also, right? So we usually take in terms of microns, micro, right? 10 power minus 6. Let me express. Then what is this dl vector? Observe here. Now we are ready with B vector. It is in Cartesian system, Az, right? So what is dl vector? Dl vector is equal to, in rectangular coordinate system, dx into ax plus dy into ay plus dz into az. Okay, now we came to know what is dl, what is b, what is I. We know I, that is current flowing in the loop. Now don't take this I, right? So current flowing in the loop, so this we have to take 2 milliamps now, right? So we'll apply that formula. F vector is equal to, so let me write in the next slide itself. F vector is equal to minus I closed line integral of B cross dl, right? Let me write it. Yes, minus I, minus 2 milliamps, right? This is 2 milliamps, 2 into 10 power minus 3. So open bracket. So we will split this integral here. First along this path. Next here. I have to integrate throughout the closed path. Let me take it one by one. A to B, B to C, C to D, D to A. So that it will be integration along the entire closed path, right? So along this closed path, what is DL we have to find out. So from A to B. So from, let me write it, AB plus BC plus CD plus DA. Sorry, DA. B cross DL. Is it fine? So what is the value of X? So because we have, okay, let me write it later. I will not confuse you people. Right, minus 2 into 10 power minus 3. Open bracket. Along AB, right? So along AB, observe here, along AB. What is DL? DL is equal to DX into AX. Because there is no dy into ay, dz into az along AB, right? Only x component is present. So dl is dx into ax. So dl is nothing but dx into ax. Then what about this b vector? 3 into 10 power minus 6 az. Let me write b vector here. B vector is, let me rewrite it, 3 into 10 power minus 6 az. 3 into 10 power minus 6 az. This is fixed. Then what is dl? Along AB. Along AB, let me write it here. Along AB, dl is nothing but dx into ax. Is it fine? So first, so I want b cross dl, right? So take the cross product, az cross ax. Is it fine? Let me check it. Oh, one mistake I have made, nobody has told. Please see here, I have made a mistake, but you should be attentive. So x I have left, no, divided by x should come here, right? This x, right, divided by x. Please be attentive. By x. B cross dl. Let me write it. Integration of 3 into 10 power minus 6 by x. This x I had left out. So az, then cross of dx into ax. Okay. This is along AB. Along AB, what is the value of x? Let me check it. Along AB, what is the value of x? We'll see later, right? So anyhow, it is the integration with respect to x only, right? This will come along. This is AB over. Then next BC. Along BC, what is DL vector? Let me find out. Along BC, what is DL vector? Only y component is there, means dy into ay. There is no x component and z component. So dy into ay. Dy into ay. So along BC. So let me write it here along BC. So 3 into 10 power minus 6 by x into az. This is b, cross of dy into ay, because dl along BC is dy into ay. So what is the value of x along BC? We'll see. So BC is here, right? What is the value of x? It is 3 only, right? 3. Here also it is 3. So the value of x is fixed from this, right? It is 3. So x is 3. I can substitute here. Later on I will write here for my reference. X is equal to 3. I will substitute. Is it fine? The next CD plus, I will write it here below. So 3 into 10 power minus 6 by x into az cross along CD. What is DL vector? Along CD. Once again, it is along x axis. Only I have x component. I don't have y and z. So DL is equal to dx into ax. So dx into ax. So plus. So it is once again integration with respect to x. No need to substitute x here, because with respect to x we have to differentiate. Then CD is over. Next, integration with respect to dA. So 3 into 10 power minus 6 by x az cross along dA. What is DL vector? Along dA. So it is here, right? It is once again with respect to y only, right? I don't have x component and z component, y. So dy into ay. I hope you are getting. So dy into ay. But observe here, what is x, value of x here, because we are integrating with respect to y, so I can substitute the value of x, dA this line, right? So x is 1 here, x is 1 here, so value of x is 1 here, so value of x is 1, we can substitute here. Is it fine? So next we'll integrate it, f factor. So 3 into 10 power minus 6 everywhere I will take it out. So minus 2 into 10 power minus 3 into 3 into 10 power minus 6, I am taking it out here. 3 into 10 power minus 6, 3 into 10 power minus 6 everywhere, right? Then next, in the first, what I am left out, integration of 1 by x, az cross ax I want to find out. Let me, we know the cross product of unit vectors ax, ay, az. I will go in cyclic manner. This in the first chapter we have studied. So I want az cross ax. What is az cross ax? Az cross ax. So az cross ax is ay. So az cross ax is ay. I will write ay here. So then integration of 1 by x. This is already taken out. Integration of 1 by x is ln x. Ln x. X is varying from where to where? Observe along path AB. Along path AB, x is varying from 1 to 3. 1 to 3. So x is varying from 1 to 3. So az cross ax is the ay. Write it. I hope you are getting. Then next, ab is, this is over. Next, come to the second integral. So substitute the value of x here. So 1 by 3 will come into picture. Yes. So this is taken out. So 1 by x is nothing but 3 here. So 1 by 3 we will take it outside, plus 1 by 3. Az cross ay I want. Az cross ay. So az cross ay, I am going in reverse direction now against this cyclic pattern. Az cross ay is minus ax. So az cross ay minus ax I will get, but it is the integration with respect to y, this constant here, right? So integration of y, y is varying from along BC, y is varying from along BC, y is varying from 0 to 2, y is varying from 0 to 2. This is over. We have substituted the value of x here, right? The next, coming to the part third integral. So once again we have to integrate with respect to x. This is already taken out. Az cross ax. Az cross ax is ay, right? So we will write ay later. So integration of 1 by x is ln x. But along path CD, x is varying from, observe here, along path CD, x is varying from 3 to 1. 3 to 1. Be careful with the limits. Here it is 1 to 3. Here along path CD 3 to 1. Then az cross ax. Az cross ax is ay. Write it. Then next, last integral. Substitute the value of x as 1 here. We have substituted 1 by 1. We will leave it. Then once again we have to integrate with respect to y. What is az cross ay? Az cross ay is minus ax. So minus I will be taking outside here. Right? Az cross ay is minus ax. Ax I will write later. Minus sign is taken out. Integration, right? This is 1. We have substituted. X will vanish. So integration with respect to y. So value of y is where d to a. Along path dA, value of y is varying from 2 to 0. 2 to 0. Right? It is 0 to 2 here. It is 2 to 0 here. Anything we have missed out? Just check it. Yes. What I have to write? Az cross ay is? Az cross ay is minus is already taken. Ax I have to write. Okay, we will solve this. What we are going to get? 10 power minus 3. Once again I have made a mistake. This is 10 power minus 3. People will keep quiet. Please tell. 10 power minus 3. Right? Into 3, 10, 10. Okay. Minus 3 to just 6. Into 10 to the power of minus 6 minus 3, I think. Right? So minus 9. 3 to just 6. 10 to the power of minus 9. Into. Let me check it. Whether they will get cancelled, you check it. Ay, this one. Limits are exactly, let me substitute upper limit minus lower limit. Ln 3. Ln 3. Minus ln 1. Upper limit minus lower. Ln 3 minus ln 1 is 0. I will not write. So ln 3 into ay I will get. The next. So upper limit minus lower limit. 2 minus 0 is 2. 2 by 3 I will get. 2 by 3. But I have not written the unit vector here. Second term, please check it. What is the unit vector I am going to get for second? Az cross ay. Az cross ay is minus ax. So I will get minus ax here. I have left it here. minus ax. So this will be minus. I hope you are getting az cross ay. Az cross ay is minus ax. Yes, fine. So minus upper limit 2 minus 0, 2 by 3, minus 2 by 3 into ax. So do it slowly, don't go wrong. So next, upper limit minus lower, ln 1 is 0, minus, so I will take minus here, ln 3 into ay. Then next, upper limit minus lower limit, 0 minus 2, minus 2 minus 2 minus plus 2 ax I will get. Please check it. This one they will get cancelled. So next I am left out with minus 6 into 10 power minus 9. So this one minus 2 by 3ax plus 2ax. So calculate minus 2 divided by 3 plus 2. Minus 2 divided by 3 plus 2 into ax we will do later. So 1.33, right? 1.333 ax I am getting. Just write down the force vector. So into minus 6 I will write. So I am getting it as minus 8. This into minus 6 is minus 8 into 10 to the power of minus 9 ax newtons. I hope you are getting. Minus 8 into 10 power minus 9 ax. Nano means 10 power minus 9. So minus 8 ax, right? Minus 8 ax. Nano means 10 power minus 9. I hope you got this. If any doubts, you can unmute yourself and talk to me so that I can clarify the doubt. Okay, this is the last problem for today's class. We'll wind up the today's class by solving this. Yes, a conductor 6 meter long lies along z direction with a current of 2 amps in az direction. Direction is very important. Find the force experienced by the conductor if B vector is given. Right, it is a straight conductor. Observe here. Just let me try to draw it. X, Y, Z. A conductor 6 meter long lies along Z direction means, right, with a current of 2 amps in AZ direction, along Z direction, right? So let me take it 6 meter, right? From 0 it is 6 meter, right? So current, this is total 6 meter, L equal to 6 meter in Z direction with a current of 2 amps in AZ direction. So current I of 2 amps is flowing in AZ direction, right? So this is a straight conductor. So we know the formula I. So it is not a, observe this, if it is closed conductor we will be using this formula, but it is a straight conductor, right? So IL cross B we will be using this, IL cross B for the straight conductor. So IL cross B. So we know the current I, right? We know B vector is given. Then what is L vector I want? So L vector is, the magnitude L is 6 meters. It is along which direction? It is lying along Z direction. So AZ, 6 AZ. I hope you got it. 6 AZ. So this is L vector, this is B vector. I is 2 amps, right? So I equal to 2 amps. So you'll find out F vector is equal to I is how much? 2. Then L cross B, what is L? L is 6 AZ cross B vector is given 0.08 AX Tesla. Okay, so AZ cross AX I want, right? So we have AX, AY, AZ in cyclic direction. Next I want AZ cross AX. AZ cross AX is nothing but AY. So AZ cross AX is AY. So I am getting AY. So 6 into 0.08 I will do first. 6 into 0.08. I am getting 0.48. 0.48 into 2. 0.48 into 2. So I am getting 0.96. But AZ cross AX is AY. So newtons. I hope you are getting. So F is equal to 0.96 AY newtons. The solution is there here, 0.96 AY newtons, right? So we will wind up the today's lecture.